Hello guys and welcome to my course of Jetpack Compose. I am Jitendra Pratap, your instructor in this course. I have more than 8 years of experience in software development and around 5 years of experience in Android application development. In this course, you will learn Jetpack Compose from scratch and I will explain everything. So let's see what you will learn in this course. So in this course, you will learn how to make an image repository app using Retrofit, Room Database and Dagger Hilt. We will use material theme to build the components. So this way you will learn all the basic building blocks of Jetpack Compose. You will also learn how to create routes for navigation in Jetpack Compose. So in this course, we will use Retrofit library to make network API request using OK HTTP client from the app to a repository, and we will use get request to fetch the data from repository. You will also learn how to use coil image library to fetch image from network and display it in the app. And along the way you will learn what is coroutines and flow and how and when to use them. Once we successfully get the data from the repository, we will inject the data in room database using Dagger Hilt dependency injection, and once it is successfully injected the data into room database, we will query the room database using the DAO interface to get the data from room. So what skills you need for these skills? So for this course there is no particular requirement because I will explain everything, but if you have some basic knowledge of Kotlin, then it would be a bit easier for you to get all the concept. But even if you don't have experience with Kotlin, you can still enroll in this course as I will explain everything. And you need enthusiasm because we are not doing anything new. It is just in Jetpack Compose we do things a lot differently compared to XML based Android app development to achieve the same goal, but it's quite efficient and time savings. Once you get your hands on Jetpack Compose, you can do app development on a much faster pace compared to XML based app development. So what tools are required for this course? So you need Windows 10, Android Studio, Bumblebee, Canary 10, and you need minimum of 8 GB RAM if you want to run your app on emulator. If you don't have 8 GB RAM, then you can use your physical device because Canary required a lot of resources to run the Android Studio, and running emulator on a machine which does not have at least 8 GB RAM will most likely freeze your machine for a very long time. So I hope that you are very keen to learn Jetpack Compose as it is going to be the future of Android app development. So now I will demo the main app, which is the main project in this course. So it's an image repository app. It displays list of mountains and their name and height. And the UI part in this home screen will be built using constant layout and staggered vertical grid. We will use constant layout to constant these three components, which are images, its name and height. And then we will use staggered vertical grid to place all the images in two columns. And although I am using staggered vertical grid, we will use the same column width for all images for consistency. Basically what happens in staggered vertical grid is you get multiple images of different heights, but for the sake of consistency of images, I will use same height and column width for all images. So all images will align perfectly with each other, as you can see in this demonstration. So to get data from the network, we will use Retrofit library to make network API request. So to get data from the network, we will use Retrofit library to make network API request using OK HTTP client and an interceptor from the app to an image repository which I have posted on Git. The repository itself is not a proper REST API repository, but it simulates like a REST API and meet all the requirements quite well for this project. And we will use get request to fetch the data from the repository. So once we get the data from the repository, we will inject the data in room database using dagger hilt dependency using constructor injection. In constructor injection, we define the list of required dependency by specifying them as a parameter to the class constructor. The class that needs the dependency must expose a public constructor that takes an instance of the required dependency as a constructor argument. And once it successfully injects the data into room database, we will query the room database using the DO interface to get the data from the room and display it in the app. So by saving all the data in the room database, your app don't have to make a network API request every time you open the app to get the data from the network, because it already has all the data, and it will make network request when there is an update in the repository. And so even if you are offline, you can use the app and can see all the data. Although the app make network API request every time you open the app to see if there is an update in the repository. If there is no update in the repository, then it will simply load the data locally from the room database. We will also create an app bar to show the title of the app and a bottom navigation bar tab to switch between the two tabs that we have built. So this is the first tab and this is the second tab. So in the second tab, we will build a list layout for same data using lazy list column to see all the images name and height in a list view. And then we will build the detail screen to get the full size of the image and its detail. So if I click on this image or the text or the height anywhere, we will go to the detail screen, and here we can get the full image of the mountain, the name, the height, and its description. We will use composable navigation to navigate within the app, and we will also create a little arrow to go back to the main screen. So if I click, we go back to the main screen, which are the two of the home and list screen. So this one is home screen and this is list screen. They both contain same data but in a different view. In this lecture, we will download the Android Studio. So if you have Android Studio Artist Fox or later on your machine and your emulator is already set up, then you can skip this lecture. Otherwise, you can continue watching this lecture. I am just going to download Android Studio from the official website. So here we need to say Android Studio Bumblebee download, and it will take you to the preview link. So we can go to preview link. And here we have two build, the Bumblebee and the Chipmunk. The Bumblebee one is more well tested, and this one is very lightly tested as it's written on the website itself. I have built the course on Bumblebee, so I suggest you to download the Bumblebee version. So I am not going to download it because I have already downloaded it to save time. You can see it on my downloads. But all you need to do is to click on this link and accept the license term here, and you click this link and the download will start. So it's started, but I don't need to download it because I have already downloaded it. So I'm just going to cancel it. Now after downloading the zip file, all you need to do is to extract this zip file and you will get a folder like this. So you can place this folder anywhere in your drive, and basically this is installed version, so you don't have to do much. You just need to go in this folder and in the Android Studio folder, and inside this Android Studio folder you need to go in the bin folder and you need to click this executable file, the Studio 64. So I am just going to click it now and the studio will open. So it has started opening and it's going to take some time. So now the studio has started, and first thing we need to do is to create our emulator. So here on the top right corner we have these three bullets. We can click on them, and here we have bunch of options. So we can select the virtual device manager to create new virtual devices. So as you can see, I already have three devices. To create a new one, you just need to hit this button, and here the phone is already selected, so you don't have to change it. And from this list you can select whichever specification you want to have it as an emulator. So choose whichever you want and then click next, and then you need to select a system image. So you will have to download one of these. I have already Oreo on my system, so that's why it's not showing downloaded. But if you want some other like Pi or Q or R or S, you will have to download it and then select the system image and click next. And here you just have to give it a name. So give whatever name you want to give it and hit finish, and your emulator will be ready. So that's it for this lecture, and I will see you in the next lecture. So after downloading the latest Android Studio, we need to create a new project. So let's create it. Choose the empty compose activity, click next, and we can say image repository app, and package name you can select whatever you want, and choose the save location. Choose the minimum SDK to API 21 so it can reach to the maximum users, and hit finish. Now we need to define some basic dependencies for this project. So let's go to our project build.gradle file, and here we have a extension for our compose version. So this is the extension we are using. So it's been used here in our app level build Gradle module. Here we are using the compose version, but this is not enough and we need more dependencies. So the first thing we need is a Gradle build tool. So let's define a Gradle build tool. And the version number is going to be 7.0.0. Now we need to declare the Android plugin for Gradle. So to declare the plugin, we need to create a dependency block. So we can write dependencies, and it appears the first. We can choose this one. No, not this one. Sorry. Dependencies. And in this block, we are going to define the Gradle plugin. So to define, we can say class path and remove the curly braces, small braces, semicolon com dot android dot tools dot build, and here we can select Gradle. So instead of directly using the extension number, we can define extension here in this one, and then we can pass it here by providing a $sign, and then we can say Gradle build tools. So if we need to use the same version again, we can just use this extension, so we will not be confused if we accidentally use some other version number. So just for that, you can create extensions here in extension block, and it will be easier to use these extensions. So after that, we need to define version for Kotlin. So we can define in extension again, saying Kotlin equals and this one is going to be 1.5.10. And then again we need to define the plugin for Kotlin as well. So we can say class path org dot jet branch dot Kotlin dash Gradle, and we also need to dash provide plugin, so we can say dash plugin, and then we can pass the extension for Kotlin, so $sign and Kotlin. So now we need to define the repositories for our project. So to define repositories, we can say repositories, and there are two repositories basically that we use. So those are Google and Maven Central. So we can just declare it here. Now we need to define the plugins for Kotlin Capped and Kotlin Android in app level build Gradle file. So we need to switch to build.gradle, and here we can define the plugins. So to define plugins, we can say id Kotlin dash capped, and for Kotlin Android we can say id and org dot JetBrains dot Kotlin dot we already have actually, I did not see that, but we already have the plugin for Kotlin Android, so we don't need to define it. So let's sync it and see if we get everything right. So and we have a failure here, so seems like we missed something. So it's a class path could not find org.JetBrains Kotlin. So let's see what went wrong here. So this is where the problem is. So seems like I forgot to provide the full naming convention, so that's why it's showing error. So here we can say just forget to write the Kotlin, and I think now we will be fine. So let's run it again, and this time it's we were able to successfully sync our project. Now we need to create a data class for the app where we can store the variables for our data. So for that we need some dependencies for room database. So the room is an ORM, object relation mapper, for SQLite database in Android. It's a part of architecture component. It makes using SQLite much easier for you by implementing annotations. So you must be wondering why we cannot use the SQLite directly. Well, actually you can use the SQLite directly, but it has its flaws, and the biggest drawback of using SQLite database directly is that it only throws runtime exception, which means that if you have any error in your query, it won't detect on compile time. You will only know about it when you actually run the app, and by that time you might have write a lot of queries or a very big query, and it can become very difficult to identify the error, because it does not give you any syntax error, so you will have to manually check it every line by yourself. However, with room database, you can identify the errors in your query at compile time and can prevent the app from runtime exception. So there are three main components in the room database: the database itself, entity, and a DAO, which stands for database access objects, through which we access the database. So this is a little slide to understand the room database. So this is the entity that we are going to create in this lecture. So an entity basically holds the field values, and then we are going to have a data access objects, which is an interface which is used for accessing the database, where we will create our functions, or you can call it queries, and then when we can use those queries to access the room database. So let's create the entity first. But to create an entity, we need to define or declare the room database dependencies. So let's create our room dependencies first. So we will go to the project build Gradle file, and here we need to define the version for room. So room version equals 2.0, my numlock is off, so 2.3.0. let's sync it. Now we need to define the dependencies for room in our app level build Gradle file. So I can type here room, and the first one is going to be the Android room time, and so I can say implementation, remove the small braces, Android x dot room colon room, and then we can say dash runtime. And instead of passing the room version for every dependency, we have just created a room version in our extension block, so we can pass that room version. Now we need the dependencies for room itself, so we can say implementation Android X, and we can choose the first one, Android X room ktx, and again we can remove the version number here and can pass the declared room version. And the last one is going to be the room compiler. So instead of implementation, we will use capt. So capt Android X, and we can choose the room compiler. Now we are done with the dependencies for room. So let's sync now. Now we can define our data class. So let's define it by going here, image repository app, right click, click on new Kotlin class. We can say here image, select class, which is already selected. And to make it a data class, we just need to prefix it with data, and it's an entity, so we have to annotate it with @entity. Now we need the field values for our data class, so we can say curly braces. Now we need another dependencies for compose runtime, so let's quickly declare the runtime. So we can say here implementation Android X dot compose dot runtime and then colon runtime, and here we can pass the compose version. So we need to provide the dollar sign, and let's quickly sync it. Now in the data class we need to define the primary key first. So to define the primary key we can say at primary key, and for some reason it's not detecting the primary key, so let's try again. Maybe we need to rebuild the project because sometimes it does not work straight away. So let's rebuild it. So to do that we can go to build, and first we clean the project by clean project, and then we can rebuild the project by using this rebuild project tab. It's gonna take some time. So I have now rebuilt the project, and let's see if it's able to detect the primary key annotation. So we will slowly type at primary key, and this time it has now detected. So sometimes it happens in this Android Studio that it's unable to detect the dependency straight away. So you can always go to build and clean your project and rebuild project, and it will detect the dependency again. So let's declare our primary key. So we can say val id, and it's going to be of type long. After that we need a title for our app, so we can say title, and it's going to be of type string. And after that we need another for image URL, so we can say image URL, which is also going to be of type string. And the last thing is going to be the height of the mountain, so we can say HEIGST height, also type of a string. Now we need to annotate this data class with at immutable. So we will say at immutable, which requires the compose runtime. Without this dependency we cannot use this annotation. So the at immutable annotation is a promise that all public accessible properties and field value will not change after the instance is constructed. So what we are trying to establish here is that values that we have defined here, id, title, image, URL and height, should be the same from the repository where we are trying to access the data. They should match, the repository's field value should also match with this data class, otherwise we won't be able to fetch any data. So this is a very stronger promise that the value cannot be changed even with the getter and setter function. So as long as you don't have getter and setter methods in this data class, you can use this annotation. Otherwise you should not use this annotation. So I hope that clears up with the at immutable annotation, and we can format this code with Control Alt Alt, so it would look nice. Now that we have created our data class, it's time to create the DAO interface for all the queries so we can access the database. So we need to create a package name persistence. So let's create the package. We call it persistence, and then we need to create an interface for image DAO. So we can say new Kotlin class, and here we can select the interface and we can name it image DAO. And to make it a DAO, we have to annotate it with at DAO, and now it's an interface. Now we can create all our queries inside this interface. So the first query is going to be an insert query. So we can say suspend function insert image list, and we need to pass a parameter. So here we are going to pass the images. So we can say images colon, and it's going to be of a type list, and here we need to pass our entity class. So we can say image. Choose the image class that you have created. Now we need to annotate it with at insert annotation. So here we can say at insert, and now we need to provide a strategy for images with the same primary key. So suppose if you have an image with an ID 1 and you change or update the image in the repository, but in the app you have the older image for that ID, and when you open the app, the DAO will find that there has been updated image with ID 1. So what it should do in that case? So in this case we can provide a strategy to replace the old image with the new one. So to do that, we can say here, as it already suggests in this insert annotation, you can use the on conflict method. So we can say on conflict, and here we can say on conflict strategy, and here we can say dot replace. So what it will do, it will replace the older image with the new one for the same primary key. So that's how you manage the conflict between the older values and the new values for same primary key. Now we need a function to fetch a single image. So we can say function get image, and here we need to provide an ID because every image have a primary key. So we can say ID dash, and which is going to be of type long. So we have to provide the typing also, and here we need the live data, and I guess we have not yeah, actually we have. So we going to need live data, and here we can pass the entity, our entity. So we can pass the image entity, but sooner or later we are going to need the life cycle live data dependency. So let's declare it anyway. So let's go to the project build Gradle, and here we can say life cycle version, which is going to be 2.2.0. Let's sync now. Now let's define the life cycle live data dependency in app level build. So we can say here life cycle live data, and here we can say implementation Android X dot life cycle. We can choose the life cycle live data KTX, and we can provide the version number here. So at not at $sign and life cycle version, and let's sync now. And let's get back to our DAO. So now we need to provide the annotation for the query. So we can say here at query, because it's an query. So we can say at query, and here inside the small braces we can say select asterisk from, and here we need to pass the entity class. So we can say image where id equals, and we need to pass the colon id, and it's already showing there the variable we created here. So that was the function or query to select a single image from the repository. Now we need another function or query to fetch all of the images from the repository. So we can again say suspend function get images, or let's say get image list, that would be better. And here it's going to be of type list because it's a list of images and not a single list. And here we should provide our image entity, and again we need to annotate it with at query because it's a query. So at query, and here we can say select asterisk from image, and I guess that's it. So you must be thinking, what is suspend function and why I use it in these two queries and not in this one? The thing is that when you do big calculation process, you don't want to do it on the main thread because it can take a long time to fetch all the data as we are trying to insert or load with this function. So the suspend functions allow us to do this task in background on a separate thread. So even if it takes a long time, it won't freeze the app UI and the app will run smooth. And in this query, we are fetching a single image, so we can use just the function because one single image is not going to take a very long time. So here we don't need to use the suspend function. Now the last thing related to the room database is the database itself. So let's create a class for the room database in the persistent package. So new Kotlin class, we can call it app database. We need to make it abstract because room provides an abstraction layer over SQLite database to allow fluent database access while harnessing the full power of SQLite, and room will map the database object to Java objects. Now we need to extend this class with room database. So here we can say colon room database. Now we need to call our DAO into this abstract class. So we can say abstract function image DAO extended by image DAO. We will have to make this function abstract because the room database, this class itself is abstract class, and an abstract class cannot have a non-abstract function. Now we need to annotate this class with add database annotation. So add database, and we need to provide some parameters in this annotation. So the first parameter will be entities. So entities, and we can provide it in brackets. So we have only one entity in our project, so we can say image, and colon class, and the next parameter we need to provide is the version. So we can say version, and it's going to be 1 because we have not created a database yet, so it's always start with 1. And the last parameter we need is the export schema, which have the true value by default, but we don't want to export the schema, so I can say false. So basically a schema contains the information about the structure of your database along with the history of your database versions and entities and the queries in a JSON format. So if you want to have the schema, then you can set it to true, otherwise you can set it false. So this is the end of this section in which we have set up the room database. In the next section, we will set up our network module with the help of Dagger Hilt and Retrofit. In this section, we will be building our DI and network module. So we will start with DI, which is stand for dependency injection. And as we require the components from network for DI, we will build the network components in between. So let's understand the dependency injection. So in app development, classes often requires reference to other classes. For example, a car class might dependent on an engine class. So this engine class becomes dependency for this car class because car class is dependent on class engine and need an instance of engine class to run. So there are two ways for a class to get an object that it needs. The car class can construct the dependency it needs like this. So we have a class car and it has created its own instance for engine, and here we have a function to start the engine, and then in the main function we are calling the instance of car and starting the car. So this can be problematic as car and engine are tightly coupled and you cannot use an alternative implementation for this car. If you want to have a different engine for this car, you would have to create a different class for car to have a different engine. So this is the way we do without dependency injection. The other way is that the class can get the dependency as a parameter, so that the app can provide this dependency when the class is constructed, or you can pass them into the function that need each dependency. So in this example, the car constructor would receive engine as a parameter. So in this approach, you take the dependency of a class and provide them rather than having the class instance obtain themselves. In this approach, the app creates an instance of engine class and use it to construct an instance of car class, and the engine class is separately defined, which make the connections between these two classes loosely coupled. So this is a DI based approach and it encourages reusability of car class. So you can pass in different implementations of engine to car. So that was the little introduction to dependency injection. So let's build our network model with Dagger and Hilt. So we need dependencies of Dagger and Hilt. So we need to define the hilt core version and hilt version in the extension block. So let's go to the project level build, and here we can define our version for hilt core version. It's going to be 2.37. Then hilt version 1.0.0. Now let add the class path for the dagger hilt plugin. So we can say com dot google dot dagger colon hilt dash Android Gradle plugin, and we can pass the hilt core version here. Let's sync it. Now we need to define the plugin ID in app level build Gradle. So we need to go to app level build Gradle, and in the plugin section we can say ID dagger dot hilt dot android dot plugin, and now we can declare our dependencies for dagger hilt. So here I will say dagger hilt, and the first dependency is going to be implementation com dot google dot dagger colon hilt dash android colon hilt core version. The second one is going to be the dagger hilt compiler. So we can say capt com dot google dot dagger colon hilt dash compiler colon hilt core version. And the third one is going to be hilt compiler for Android X. So we can say capt Android X dot hilt compiler, and we can pass the hilt version here. Now we can sync it. Now we need to create a package for DI. So we can go here and select, right click, new package. We can call it DI. In this package we need to create a network object. So we can say new Kotlin class, and here we need to select the object because we are creating a hilt object here. So we can say network So we need to use it as an object of instead of class to make it singleton. So it can have only one instance, and it provides a global point of access to the object. It is useful for objects which need to be shared between different parts in the app, and for resources that are expensive to create. So now we need to annotate with @module So we can say at module, then we need to annotate with at install in. So we can say at install, and for some reason it's not detecting the annotation. So we can rebuild it by cleaning the project and rebuilding it, so we can get the dependency, the annotation. So let's see if it works. So now after rebuilding, we get this error saying that the install in annotation is missing. So let's see if the Android Studio is able to detect the install in annotation. So we can say at install in, and this time now it's able to detect the annotation. And to make it singleton component, we can say singleton component : class. It basically tells Hilt to generate the components, otherwise the Hilt will not recognize this object. Now we need to create an OK HTTP client to send HTTP request and read their response. So inside this object, we can say fun OK HTTP client, and it needs a parameter. So it needs a application context. So we can say at application context. We need to provide the context with application context, and then we can say context Now we need to add the dependency for OK HTTP client. So let's get back to the project level build Gradle, and here I can say OK HTTP version, then I can say 4.7.2, and I can sync it now. Now I can define the dependency in app level build Gradle. So here I can say OK HTTP client, and here I can say implementation com.square up dot OK HTTP3 colon logging dash interceptor colon, and then we can pass the version for OK HTTP. Now we can sync it. Now we can get back to our network module, and we need to extend this function with our OK HTTP client. So we can say OK HTTP client, and inside this function we need a builder for OK HTTP client and an interceptor and a utility to set the response cache, so we can use it to read the response. So we can say return OK HTTP client dot builder. No, we need the other one. Return OK HTTP client dot builder and dot add interceptor. So here we need a request interceptor class to add, remove or transform the headers on request or response. So the HTTP headers let the client and server pass additional information with an HTTP request or response. So let's create the request interceptor class in network package. So we need to create a new package network, and here we can create our interceptor, request interceptor. So we can say request interceptor. We need to extend this class with interceptor. So extend it with interceptor. In this class, we need to override the interceptor function. So we can press Ctrl O and we need to override this function intercept. Here, chain is an interface that returns the connection on which the request will be executed. So now we need to chain our original request. So we can say, we can remove this to do and we can say val original request equal chain dot request. We need to chain this request to decide whether the data is compressed and then checksum or checksum and then compressed. Okay, HTTP use list to track interceptors so they can be called in right orders. So after this we need to build this request. So we can say val request equals original request dot new builder dot URL, and we need to pass the original request URL. So we can say original request dot URL, and finally then we can say build. Then we can return this request by saying return chain dot proceed, and we can pass the request. This chain dot proceed is a critical part of interceptor implementation. This method is where all the HTTP works happen. It produces a response to satisfy the request. So let's get back to our network module and pass this request interceptor to our interceptor. So we can say here request interceptor. We need to select this one, the one we created. Then we need to provide a method to set the response cache, so it can be used to read the response. So we can say dot cache. Something is wrong here. We also need to put the small braces here because it's a class. Then we can say dot cache. Now we need an image loading library which can fetch and display network image using coil. So we need to add another dependency for coil. So let's get back to our project level build Gradle, and here we can say coil version 1.3.5, and let's sync it. Then let's get back to the app level build Gradle. Here I can say coil image, and then implementation, and here I can say form dot github dot skydog colon landscapist dash coil, then colon, and then we can pass the coil version. Now we can sync now. Now we can go back to our network module. Here we can say coil utils. Seems like we did a little mistake with adding the dependency. So let's get back to the app.dll file, and I think there is a typo. So I think yes, and let's sync it again and let's see if we get it right. So let's try to use it again. Coil utils. Now we get it. So there was a little typo mistake. So we can say coil utils dot create default cache, and we need to pass the context here. So we can say context. Here we are trying to optimize the cache instance for coil, because by default every image loader is set up for disk caching, and will set a max cache size of between 10 to 250 MB depending on the remaining space on the user device. So this function will create an OK HTTP disk cache with a reasonable default size and location, and finally we need to call the build. So dot build. Now we need to annotate this function with add provides. So we can say add provides, so that Hilt can throw null point exception in case of an exceptions, because by default Hilt does not allow null values. And then we have to annotate with add singleton annotation to prevent it from creating multiple instances. So after OK HTTP client, we need a function for image loading. So let's create it. Function image loader, and it required some parameters. So it requires the application context. So we can say application context, and then context, and it also requires the OK HTTP client. So we can say OK HTTP client, and then we need to extend it with image loader. So we can say image loader. We need to use the coil version. So the image loader is a service class that loads images by executing image request. So they are designed to be shareable and work best when you create a single instance and share it throughout your app. So we will have to annotate with add provides and singleton. So let's do that. Now let's build the image builder. So inside the function we can say return dot builder, and here we need to pass the context or provide the context. So context, then we need to call the OK HTTP client, and we need to provide the OK HTTP client in curly braces. So OK HTTP client, and then we need to call it build. So that's it for image loader. Now we need to create a function to provide retrofit. So for that we need dependency for retrofit. So let's get back to our project build module, and in the extension block we can say retrofit version equals 2.9.0. Let's sync now. Then get back to app level build Gradle. Here we can say retrofit implementation com dot square up dot retrofit to colon retrofit colon, and here we can pass the retrofit version. So dollar retrofit version. Then we need another dependency for JSON converter. So we can say implementation com dot square up dot retrofit to colon converter dash JSON, and then we can pass the retrofit version. So let's sync now. Now we need a network response interface for handling successful data and error response. So let's declare the dependency for it also. So here we can say sandwich version, which is 1.2.0. Let's sync now. Let's declare the dependency for it. So we can say implementation com dot github dot skydov colon sandwich colon, we can pass that sandwich version. Let's sync it. Get back to our network module. Now let's create the function for providing retrofit. So we can say function retrofit, and it takes OK HTTP client as a parameter. So we can say OK HTTP client. Let's extend it with retrofit, and seems like it's not detecting the retrofit, so we can do the same thing again. We can clean and rebuild. So here we have rebuilt this again, and let's see this time if we can get it detect the retrofit dependency. Now we get it. So I don't know why it's happening quite a lot lately, but it does not happen very often. So let's get it on with it. Retrofit, and then we need to annotate with at provide and at singleton. So at provide at singleton. Now we need to create the retrofit builder inside this function. So we can say return retrofit dot builder, and then we can say dot client. We need to provide the client, so we can say okay HTTP client. Then we need to provide the base URL. So the base URL from where we will provide the data for this app. So I will quickly show the repository for the app. So this is the link where I have created a small repository of mountains with their height and description and image URL. So I will put this link in the resource so you can get it from there. And what we need is we need to click this raw, and it will take it to this link. So we have to copy this link, and we have to copy until this point. So we have to copy all the link until this point and put it on our base URL here. So we can say base URL from where we will fetch the data. After that, we need to provide the converter. So we can say add converter factory, and we are going to use the JSON converter. So JSON converter factory dot create. So we need JSON for serialization to and from JSON. Then we need to call the adapter factory for supporting service method return types other than call. So we can say add call adapter factory, and here we need to pass coroutines response call adapter factory. So we can say coroutine response call adapter factory dot create. Then we finally call the build method. So dot build. Now we need to create an interface for image service where we can set an endpoint and an API response. So we need to create a package for it. So we will say new package, and we can call it network. Network is already, oh, we have already created the network package. I forgot, sorry. So here we need to create the interface for image service. So we can say new Kotlin class, and we need to select interface, and I can call it image service. So inside this interface we create a suspend function. So suspend function, and we can call it retrieve image list, and we need to extend it with API response. So I can say API response, and we need to provide the list of images. So we can say list and pass our image model class. There is a typo mistake, so I can. Now we need to annotate this function with a get. So we can say add get, and we need to provide the endpoint for it. So the endpoint will be this link. At the end of this link we have this image.json. So this is the endpoint for the service. So we can copy it and paste it here. Now we need to use this interface in network module to provide the image service through retrofit. So we can go back to our network module, and here we can say function provide image service and it required retrofit as a parameter, so we can say retrofit. Then we need to extend the image service that we created. So image service, inside this function we can create this service by saying return retrofit dot create image service class dot java. So that's it for the network module, and next we will build the persistent module. Now we need to create a persistent module so Hilt can communicate with room database, because we want to save the data in local storage, so the app will not have to fetch data from network every time you open the app. Once it's saved in the database, it will be loaded from room database. So let's create the persistent module. So new, we can call it persistence and choose the object and notate it with at module. Then we need to annotate it with at installing. And it requires a parameter, so single component class. We need to specify this requirement to make this object available in the application container. Now we need to provide an instance of image DAO. So let's say fun provide image DAO, and it requires a parameter of our database. So we can say app database, and then we need to extend it with our image DAO. So we can say image DAO. Then inside this function we can say return app database dot image DAO, and here I have a little typo again, so I need to correct it. So this code tells Hilt that app database dot image DAO needs to be executed when providing an instance of image DAO. So then we need to annotate with at provides. So we can say at provides. With at provides, it will be executed every time Hilt needs to provide an instance of that type. Then we also need to annotate with at singleton to make it singleton. Since the project does not own its own database because it's generated by room, so we cannot constructor inject app database, but we can use at provide functions to provide it. You will get to know construct inject in upcoming section when we'll create main repository. So let's create the function provide app database. So here we can say function provide app database, and it requires a parameter of type application. So we can say application, and then we need to extend it with the app database. So app database, inside this function we need to create the room database builder. So we can say return room dot database builder, and here we need to provide some parameters. So the first parameter is application, then the second one is our app database. So we can say app database class dot java, and then it need the name for the database. So we can get it from the string file string.xml. So we can say application dot get string, and we can say r dot string dot, okay, we need to import the resource. So alt plus enter, and now here I can say database, which we don't have created yet, so let's create it. So create a string value resource database, and we can call it image dot db. Let's save it. Now we need to call our next method dot fallback to destructive migration. So you can call this method to recreate the database whenever you change the schema. So instead of crashing, it would recreate the whole database again. And then finally we need to call the build method. So dot build. Then again we need to annotate it with add provides and singleton. So this is our persistent object. So now we need to create the repository module, and for that we need to create a main repository class where we can define how and when we should call the API request and what should the app do in different scenarios. So let's create the package. We can call it repository. Let's call it main repository class. Here we will use the constructor injection for image service and image DAO. So we can say at inject, and it required constructor. So we can say constructor. Inside this constructor, we define our variables for image service and image DAO. So we can say private val image service, then private val image DAO. So by declaring these dependencies via injection constructor, it guarantees that this dependency will always be available to the class that we are currently developing. And by requiring all the callers to supply the dependency as a parameter to the class constructor. So when a class requires an instance of a dependency, you can supply that dependency through the class constructor, and it enables it to store the reference for future use. Constructor injection is the act of statically defining the list of required dependency by specifying them as a parameters to the class constructor, and the constructor signature available for all to see. Now we need to initialize it. So we can say init, and here we can just log it. So we can say log d, and here I can say image repository, and I can say just a message injecting main repository. Here we need d log.d. Need to import the log. After that, we need a function to load images. So we can say function load images, and it need to be annotated with a worker thread. So we can say at worker thread. So worker threads are background threads. They are the threads that are created separately other than the main UI thread, and we should not run this function on main thread since it's a service and not attached to an activity or fragment. And since blocking the UI thread is restricted according to the rules, and the user should run the child processes and tasks in worker threads. Now we need to create three methods for on a start, on success, on error. So here in the constructor we can say on start it's going to be of type unit. Unit means it does not return anything. Then on success, again going to be unit type, and then we need on error. So we can say on error, and it takes a string as a parameter because it's going to be a message. Now we need dependencies for coroutines because we need coroutines flow. So let's declare the coroutine dependency. So we can go to the project module build. Here I can say coroutine version. It's 1.4.1. Sync it. Then in the app level build Gradle, we can declare the coroutine dependency. So here I can say coroutine implementation org.jetbrains .kotlinx kotlinx dash coroutines dash android colon, and then we can pass the version. Coroutine version. Now we can sync it. Now we can use flow. So flow is a type that can emit multiple values sequentially as opposed to a suspend function that returns only a single value. For example, you can use a flow to receive live updates from a database, which is what we want to achieve here. So here we can say equals flow And now we need to provide the flow collector. So here we can say val images, which is type of list. Then we need to provide our image model data class. Then we can call our get image list from image DAO. So we can say image DAO dot get image list. Now we need a if else statement to check whether we have images in database or not. So we can say if images, and we can check it by saying is empty. Then we will request API network call from image service. So here we can say if the database is empty, we can say image service dot retrieve image list. Then we need to handle API response for success, error and exception. So we can say dot suspend on success, and here we can say image DAO dot insert image list, and we need to provide the data for it. So we can say data. Then we need to call the emit function with data as parameter. So we can say emit and provide the parameter data. Then for error, we need to set API response. So we can say dot on error, and here we can just set the message. After on error, we need to set the response for exception. So here we can say on exception, and we will pass the same message here. Then in the else part, which is right here, if the database is already loaded, then we can just say emit for images. Then we need to call on start function. So here we can say dot on start, and we can pass the on start function here. Then here we can say dot on completion, and we can pass the on success method that we created earlier. We can pass this function, and then we can call flow on. So here we can say dot flow on dispatcher dot IO. We need this flow operator to change the context where this flow is executed to the given context, because by default the producer of a flow builder execute in the coroutine construct of the coroutine that collects from it, and it cannot emit values from a different coroutine construct. This behavior might be undesirable in some cases, because the repository layer should not be performing operations on the dispatchers.main. So to change the coroutine construct of a flow, we use this intermediate operator flow on. So looks like we are done here for the main repository class, and this error function has not been used. Seems like we have left something. Okay, so we need to pass this on error function here on exception, and not just the method. So we can say on error with the message, and yeah, we are done for this main repository class. So next thing we are going to build is the repository module. Now we can create repository module. So in DI we create our repository module object. So we can say repository, and we need to select the object. In this repository module, we just need to provide the function for main repository. But before that, we need to annotate it with at module, and then we need to annotate it with install in, and we need to provide view model component colon class. So the view model component has the lifetime of a single view model. This hilt component is the source of a hilt view model. It contains a default binding for the save state handle associated with the view model that can be used by other dependency provided by the component. So dependencies in the view model component can be scoped using the view model scope annotation, which we are just going to use. So here we can say function provide main repository, and we need to provide the image DAO and image service as a constructor. So we can say image service, and then image DAO. So image DAO, and then we need to extend it with our main repository that we created in the previous section, and then we can just call it the return function for main repository, and we need to provide these two parameters. So we can say image service and image DAO, and we need to annotate it with at provides. So we can say at provides, and then at view model scoped, and we are done for the repository module. So this is it for the backend part, and from next section we will be working on our front end. So I will see you in the next section. So from this section onwards we will be building our front end, but before that I need to do some correction, because in the last section I made a mistake here on error. So here I need to pass the on error function and not just the message. So I can say on error, and we need to pass this message in the arguments. And now we can move on with our front end. So the first thing we will build is the home screen, in which we will show all the mountains images with their name and height in a staggered vertical grid. So let's create a package for screens. So here I can say new package screens, and in this package we need to create a Kotlin class, not class, file. So I can say home screen. So the first thing we will create is a composable function to display a single image. Then we will create another function to pass this function in the staggered vertical grid. So let's start with add composable. Here we can say fun function display image, and it's going to need some parameter. So the first thing will be the image itself. So we can say image. It should have imported, but it did not imported the image from my package. And the second is we need a function to select the image. So we can say select image, which is going to be of type long. Then we need a modifier. So modifier equals modifier. So I think it is the first time you are seeing the modifier. So we use modifier to decorate or add behavior to compose UI elements. For example, if we want to set a background or give a padding to an image, then we will have to use modifier. So inside this function, we need to have a surface. So let's say surface, and we need to remove the import here. So surface is a central metaphor in Jetpack Compose. It influences how a piece of surface visually relate to other surface, and it also responsible for clipping and shaping and providing color and adding border and setting elevations, and most importantly handling click events. So we can say surface inside this small braces, we can say modifier equal modifier dot padding. We want some padding around the surface, so we can say 4.dp, and we need to import the dp. So add plus enter. Then we want to have a clickable effect on the image, so we can say dot clickable. Not this one, but this one. And inside this clickable function, we can provide on click function, and in this on click function we can pass our select image function, and we can provide the id for image. So we can use this image variable to set the id. So we can say image dot id. So now we are done with modifier, and now we can set the surface properties after modifier. So let me see. So here we can say comma color, and we can say material themes dot colors dot background to set the background color, and then we can set the elevation. So for elevation we can say elevation equal 8.dp, and then we can also provide a shape for our surface. So we can say shape equals, and we can say rounded corner shape, and here again we need to provide the dp. So it will be 8.8 After defining surface, we can define the screen component, and for that we need to use constant layout. So we will be needing the dependency for constant layout. So let's add the dependency. So in the project level build Gradle file, we can say here constraint layout version, and which is 1.0.0 dash alpha 07, and then we need to sync the project. Now we can declare the dependency in the app level build Gradle. So here I can say constraint layout. So many typos. Anyway, this is not necessary. So here we can say implementation Android X dot constraint layout, and I guess we can select the constraint layout compose, and we just need to pass the version, constraint layout version, and we can sync now. Now in the here we will define the constraint layout. So we can say constraint layout, and here we need to create references. So what are the items that we are going to have in the screen? So there are 3 items that we will have. So we will have 3 UI items in the constraint layout, and those are the image itself. So we can say image pic, and I am using a different variable name because I have already used the image variable name. So image pic, and the second element will be title. So we can say title, and the last element will be height. So we can say height, and then we can say create reference. So that's how we create reference in constraint layout in Jetpack Compose. After this, we need a function to display the image from network. So now we need a custom network image function. So let's create this function so we can fetch the image from network. So we will create a new package, and we will call it util, and here we need to create the network function. So we can say network image, here we will start with at composable, then we can say function network image, and this requires some parameter. So the first parameter will be a URL, since it's fetched from network, from internet. So URL of type is string, and then we need a content scale because we need to crop the image. So we can say content scale dot crop. Then we will be needing the modifier. So you can say modifier equals modifier, and after that we can set the coil image library. So we can say coil image, and we need to choose this one, image model. So again I need to remove this import. Sometimes it import all the text in the function itself and also here. So you can remove it always if you get it here also. So image model, for image model we can say URL, and after that we need to provide shimmer params. So we can say shimmer params, and we need to provide a color for it. So we can say base color, and then we can say material theme dot colors dot background, and we also need the highlight color. So we can say highlight color, and for this we need to create a new color so that we can highlight. So we can go to our UI package, and here in colors file we can copy this value and paste it, and we can say it shimmer highlight, and we can choose a color from here. So we can click it, and I want to have, I guess, this color around here, and after that we can get back to our network image, and for highlight color we can say shimmer highlight. And what else, we also need modifier. So we can say modifier equal modifier, and we also need the drop off. So we can say drop off. So it's going to be 0.6.5 f. So it can adjust the size of the fading edge of the highlight. And after modifier we can set a response in case of failure for image request. So we can say failure, and we can use a text here. So we can say text, and we can provide the text here. So we can say image request failed, and you can provide a style for the text. So you can say style material theme dot typography. Typography is used for styling the text. There are number of options, you can select whichever you want. I am going with body 2. The others are very big actually, so be careful there. And yeah, I guess we are done for the network image. So we can get back to home screen, and here now we can call our network image. So network image, so for URL we can pass the image dot image URL, and we also need the modifier. So we can say modifier equal modifier, and now we need to constrain the image. So we can say dot constraints as and we need to pass the reference that we created, this one. So we need to pass the image pic reference here. Then we have to provide the scope for it. So we can say center horizontally to, and we can say parent, and then we need to link the top to the top of the parent. So we can say top dot link to parent dot top, and since it's an image, so we need to provide a aspect ratio for it. So here we can say dot aspect ratio, and I can say 0.8 f. So after image, we need to create the constant for title. So here we can say text, and for text we can use the image dot title. Then we can provide some styling. So we can say comma style. Again we are going with the material theme dot typography dot body 2, and then we can align it to center. So we can say text align and text align dot center, and then we need to constraint it. So we can say modifier equal modifier dot constraint as, we can say title. Then we need to provide the scope for it. So we can say center horizontally to parent to make it in center of horizontal, and then we need to link to the bottom of the image. So we can say link to, and we can say image pic. So now this time we are going to link it to the bottom of the image. So we can say image pic dot bottom, and here we need to provide the top actually. So top to the link of image bottom, and then we need to do the same thing with the height. So we can just copy it and paste down here, and for text we can say image dot height, and for constant we can provide the height. Here we can say top dot link to title dot bottom, and we also need some padding for both of these text. So here I can say dot padding of 8 dp, and for this one we need to set both horizontal and bottom padding. So horizontal 8 dot dp, for bottom we can say, here we can say dot padding bottom, and we can provide 12 dot dp. So that's it for the single image, display single image or display image. So after creating function to display a single image, now we need to create a composable function to display the list of images. So we can say here add composable function display images, and here we need a list of images. So instead of just image we can say list, and then we can provide the image data class here. Yeah, after that we need the function to select the image. It can remain the same as display image, and then we need the modifier. So we can say modifier, and then we can initialize with the modifier. Now we need a column where we can put our display image function in a staggered vertical grid. So let's define our column. So basically a column is a composable layout in which you can put your UI elements in a vertical sequence like you do in XML with linear layout having vertical orientations. Now we need to initialize the modifier, so we can say modifier equal modifier, and now we need to have a scrolling behavior because it's a list of images, so it can be very long, so we need this scrolling functionality. So we can say modifier equal modifier dot vertical scroll, and then we can use a function, a composable function, which is called remember scrolling state, remember scroll state for scrolling. So what it does is that it creates the scroll state and remember the position based on the currently scroll configuration to allow changing scroll position, and it also observe the scrolling behavior. After that we can set a background color, so we can say here dot background, and we can use material theme dot colors dot background. Now we need to create a stagger vertical grid where we can display all images in this column scope. So for that we need to create another function, so we can go to our util package and say new Kotlin class, and we need to choose file, and we can say staggered vertical grid. So here we can say at composable function staggered vertical grid, and it's going to require some parameters. So the first parameter we need is a max column width, so we can provide a column width, so we can say max column width, and which is type of DP, so we can select the DP of androidx.compose.ui.unit. Then we need we need to import the DP as well, so we can say alt plus enter. After that we need the content inside the grid, so we can say content, which is going to be of type composable, so we can say at composable provide the unit, and then we need the modifier as well, so we can say modifier equals modifier. Then we need a layout function which is used to measure and then position multiple layout children, so we can say layout, and for content we can set the content we just created, so we can set it to make content, and we don't need the measure policy, so we can remove this. And we need modifier, so we can say modifier, and we can do the same with modifier, so we can set the modifier to modifier. Now we need to check the bounds of the width, so we can say measurables constraint, we need the lambda function, and then here we can say check constraint dot has bounded width, and then we need to set a message here just in case of infinite width. So we can say unbounded width not supported. So what it does, it will return true if it has a finite value for the maxed width. Otherwise it will return false and it won't create the grid. So once it has checked the maxed width, we can then define the children's. So now we can define column for the grid. So we can say we need to define the column first. So we can say value columns. So we can say value columns, and we can get the column number of column by dividing the maxed width with the maxed column width. So we can say constant dot max width. So we will get the max width of the screen, and then we can divide it by the value that we will later provide with this max column width. So we can say max column width. Then we need to create it to pixel. So here we can just say dot to px. So it will create to the pixel, and then we need this column to be a whole integer value, because this calculation will definitely give float value, because the maxed width, sorry, it has to be maxed width, my bad. So the max width can be vary depending on the screen size. So we can convert into int by saying to the end of this curly brace, we can say dot to int. So we can get the value in the rounded number. Then we need to define the width of the column. So we can say value column width and here we can say constraints dot maxed width, and then we can divide it by the number of columns to get the column width. So it will get the width of for the column, and then we need to provide constant for the items that we will be put in the grid. So they all will be of same width as we set them. So we can say value item constraint equal constraint dot copy, and here we will set the maxed width to column width. So all the items in the grid or in the column will have a same width. So it will be only as big as column width and won't be as wider as parent of the screen. Otherwise it could take the whole screen and you won't see the second column. Next we need to define the height of the column. So we can say value column height and this is going to be of type int array, integer array, and we need to provide the columns and we need to set the initial value to 0. So we can initialize it with int array with initial value of 0, and we can pass columns as a parameter to keep track of columns, and then we can later decide the height of the column as we put the items in the column. Like when we put items in the column, it will measure how much height it needs, and then it will provide the enough height for the column. Then we need all the items that we are going to put in the column, so we can say value placeable equal measurables dot map. Here we need a measurable, then lambda function. Then we need to define which column is shortest. So we can put the next column beneath it. Of course, in our app, all the image will be of almost same height. So we can say value column equal shortest column, and we need to provide the column heights. So this function we will need to create it. We will just create it shortly, but let me finish this vertical grid first. So now we need to measure all the placeables. So we can say value placeable equals measurables dot measure item constraint, and then after measuring the item we need to add the height of that item to the column height, so the column height can increase as we add more and more item. So we can say column height and pass the column as an array because it's an integer array, and then increase the height from the height that we get from the placeable. So here we need to pass the columns, and then we can add it by saying plus equal placeable dot height. Then we can return the placeable, so we can say placeable. Now let's make the function for the shortest column. So here we can say private function shortest column, and it's going to require a parameter which is column height. So we can say column heights, which is of course of type integer array, and it's going to be of type int. Here we need to define a variable for minimum height, so we can say variable min height, and we can set it to max value, so we can say int dot max value. And then for the initialize shortest column we can initialize with 0, so we can say var column equal 0. Now we need to measure the height for each index, so we can say column heights dot for each index, and here it requires the index and the height, so I'm going to change it to height, and here we will just use an if statement to check the height. So we can say if height is smaller than minimum height, Then we set the minimum height to height. So we can say min height equal height, and then we set that index to the column. So we can say column equal index, and then we return the column. So here we can return column. So that was the function for to find the shortest column. Now get back to the staggered vertical grid, because this function still required some work. So after placeable, we need to get the largest column from all the columns we have. So we can say value height and equal column heights dot max or null. So here we are trying to see, so it will return the largest element or null in the case if there is no element. Then we have to check the height. Then we need to check the height that lies between, to make sure that it lies between minimum height and maximum height. So it should not be less than minimum height or more than max height. So we can use the course in function to constraint in. So we can say dot course in, and here we need to provide the constant for minimum height and maximum height as well. So we can say constant dot max height, and here we need to provide the question mark, which I forgot. And let's get to the second line, and we also need to set it to the minimum height. So if it cannot satisfy both of these constant, then we can set it to minimum height. So we can say question mark dot constraint. Why it's not taking? Maybe I should put it all of them in one line and see what happens. So here I can say question mark colon constant dot min height. It's too big anyway for one line. Now we need to provide the scope for the layout. So we can say layout, and it requires two parameters. So width, and we can set it to constraint dot maxed width, and height. So we will set it to the height that we just calculated above. Now we need the column position for a y-axis. So we can place them at position like 0 0, which is the highest point on the screen. So we can say value column y equal int array, and we need to provide the columns here. We can say columns, and we can initialize with 0 because we need to start from 0. So we will initialize with 0. Now we need to go through each item we want to place. So we can say placeable dot for each, and here we need the placeable followed by lambda expression. Now we can put the shortest column based on the value of column y. So we can say value column equal shortest column, and here we can just provide column y. Then we need to place it on the screen, so we can say placeable dot place. So we need to start from 0, so we can say x equal column width into column, which will give the position of 0 at x-axis, and then for y we can say column y, and we can just provide the column here as an array. So it will give us the position for the first item at the top left corner on the screen, and it will add the height of that item onto the y-axis. So when we will put the third item, it will start from that position and not from the 0 0 position. So next we need to add to the column y of the height of the previous item. So we can say column y, and we need to provide the column so it can keep track of the column, and then we can add the height, so we can say placeable dot height. So that's it for the staggered vertical grid. Let me see if we get everything right. I think I have missed something because this column is not getting used. So somewhere I have made a mistake for sure. Also we need to make this measurable and not measurables. Okay, here we need to pass the shortest column, this column, and not the column that we defined. So we can say column, and we are good for this staggered vertical grid, and it's not easy to get it first go. So if you don't understand it completely at first, then don't get panic or disappointed. You will get it by going through the code couple of times. So try to read and analyze if you don't understand it, and then it will become more clear and you will understand it more better. So now I want to use this staggered vertical grid in our home screen. So let's do that. So here we can say staggered vertical grid, and it required the max column width, as I mentioned when I was making the vertical grid. So we will provide the max column width in home screen here, and it will divide the max width so we can get the number of columns. So here I can say 225.dp. You can choose whatever you want between 200 to 250, and then we need some paddings around. So we can say modifier equal modifier dot padding of 4dp. So it will get the padding of 4dp from all sides. Then we can run a for each collection on the image variable. So we can create a param for single image and then loop the display image function through lambda expression. So we can say images dot for each, and here we need to provide an image variable and then lambda expression. and here we can pass our display image function. And image, for image we can set the image, this image variable that we just created. And for select image we can pass the select image function, and I think we are good for the home screen. So I am getting this error, so let's see what is that. Create function staggered vertical grid, which I just did. So we are getting some errors, and it is something to do with the staggered vertical grid. So let's go back to the grid, our grid, and here I made some mistakes. So here we need the ceiling to actually convert it to integer, so I forgot that one. And I think we need to provide this modifier first hand before anything else. That is the reason I think it's not working, so let's do that. And yeah, now it's working. So that's it for the home screen, and in the next section we will be building our view model. So in this section we will create our view model. So what is view model? We use the view model class to store and manage UI related data in a lifecycle conscious way. The view model class allows data to survive device configuration changes such as screen rotations and change to keyboard availability. Also in view model, we convert an app's UI data into encapsulated live data and add observer methods that are notified when the value of live data changes. So this view model will be associated with the main screen, which will create afterwards. So let's first create a package for a main screen. So package, we can say main screen, and here goes our view model. So we can say class main view model. We need to annotate with at hilt view model because it's a hilt app. If it was not hilt app, we would just annotate with view model. Then we need to extend this class to view model. So we can say view model. Then we need to inject the main repository with injection constructor. So we can say class main view model at inject constructor, and we need to import the injection. Let's define our main repository. So we can say private value main repository. Now we need to declare some mutable live data, which requires lifecycle live data dependency, which I think we have already declared. Let me check it. So lifecycle live data we need. Yeah, we declared it some time ago, so we are good to go. So let's create our first mutable live data, which is an image list. So we can say private val underscore image list mutable live data, and it's going to be of type boolean. So we can say boolean, then initialize with mutable live data, set the value to true, So mutable live data is a class and it extends the live data type class. It provides the post value, set value methods publicly, something that live data class does not provide. Live data or mutable live data is commonly used in updating data in a recycler view, or in our case lazy column, from a collection of list type. Lazy column is the new recycler view in Jetpack Compose, and it is much easier and sophisticated compared to recycler view. Also very easy to implement. So next variable we need is the loading variable. So we can say private, oh, where are we going with that? Private val, we can say underscore is loading. Also going to be of type mutable live data. We can say of type boolean, and then initial value we can set it to false. So this is loading variable will tell that whether the data is loading or not. So when it's loading it will be true, and when it's not loading it will be false. So initially it will be set to false. Then we need a variable for the toast message so that we can show error message and response. So we can say private value or val underscore toast, which is also going to be a mutable live data, but the typing will be string because it's mostly a message. Also need to initialize it with just mutable live data. Now we need an observer to observe the changes in the image list. So we can use live data, which is a data holder class that can be observed within a given life cycle. So we can say value image list of type live data, and here we need to provide our data class. So first we need to provide the typing list, then we provide our data class, which is image, and then we can set it to the value we created here, image list, and we can say dot switch map. Switch map returns the live data from the input of this live data by applying transform on each value set on this, which we are just going to create. So we can say this dot main repository dot load image. Then we will have to provide all the functions that we created in the main repository as a parameter to load image. So in a load image parameter we can say on start, and on start we can say we can set this loading to true. So we can say dot post value true. Then we can say on success, and we can set the is loading variable to false. So we can say is loading dot post value to false, and then we need the on error. So we can say on error, and on error we will just provide the toast value. So we can say toast dot post value, and we can just say it. So on start we can say is loading is true. On success we can make it false, so we can stop the loading. And on error we can post the toast message by providing it. because the error messages are already declared in main repository. Afterwards, we can call the calculation as a live data function on this. So we can say dot as live data, and it requires a coroutine context, because coroutine context include a coroutine dispatcher to determine what thread or threads the corresponding coroutine uses for its execution, because coroutine always execute in some context represented by a value of the coroutine context type. So let's create the coroutine context. So for that we need an extension for this view model. So let's create the view model extension. So where should we create the extension? Let's create a new package for extensions. So here we can say extensions, and we can call it view model extension. And we don't need class, we can just say value view model dot view model IO context of type coroutine context. And now we need to call inline function to attach the dispatcher to our coroutine context. So we can say inline get, and we can say view model scope dot coroutine context plus dispatchers dot input output. So we inline function to reduce runtime overhead, because in Kotlin all high order functions are stored as an object. So memory allocation for both functions object and classes and virtual calls might introduce runtime overhead. So inline keyword requests the compiler to not allocate memory and simply copy the inline code of that function at the calling place, and then we append the dispatchers.io input output, which is optimized to perform disk or network input output outside of the main thread, because this load image function is running on a worker thread, as you remember, and not on the main thread, and which requires optimizations. Now we provide this view model input output context as a parameter to our live data function in our main view model. So here we can say view model input output context. Now we also need an observer for our toast, so we can say value toast of type live data, provide the string, and we can say get, and we can set it to toast. So get function is used to set a getter like we do in Pojo classes. So that's it for the view model, and we will add more items as we require them as we build our app. So the next thing is we are going to build our screen where we will create the main screen. So after creating view model, now we need to use this view model to set our screens. So let's create a screen function in screen package where we will unload all our repository data. So in screens, create a new Kotlin file. Let's call it screens. So before we build our screen, we need to first create an app bar. So let's create the app bar first. So we can say add composable function app bar. Here we can bring the top app bar from material design. So we can say top app bar, and we can give some properties to it. So we can say elevation 6.dp, and we can give it a background color. So we can say background color purple 200. Let's bring it down to the second line, and let's give it a height. So we can say modifier equal modifier dot height, and let's give it 45 dp height. Then we need to provide a text for it. So let's say text, and for text we will use string resource to get the name of the app. So we can say text equal string resource, and here we need to provide the id for it. So we can say id r dot string dot app name, and I guess I have to import the resource, otherwise I cannot access it. So let's import it, and r dot string dot we can say app name. Then we can provide color for it. So we can say color equal color dot white. So color dot white, and we can give some font size. So we can say font size 18.sp, and then we need to import the sp as well, and then we can give some font weight. So font weight we can say font weight dot bold, and let's give some padding. So we can say modifier equals modifier dot padding of 8 dp. So we can say 8.dp, and then we can align it to center vertically. So we can say alignment dot center vertically. So that's our app bar. Now we need to create the tabs for bottom navigation. We are going to have two tabs. So we need an enum class to create constants for the two tabs, and each tab have a title and an icon. So let's create an enum class. So enum class we can say image tab, and we need to provide the two parameters for title and icon. So we can say here, so we will use the titles from the string resource file because we should not hard code string variables. So to declare a string resource variable, we can say at string resource or string res val, we can say title of type int, because we have already declared it as a string resource, and in a string resource all the string resource have their unique ID, so we fetch them using the ID and not string. And this is something Android Studio does under the hood and take care of it by itself. For icons, we can simply declare them as image vector. So we can say val icon of type image vector. Now we need to define the two tabs here, which are separated by a comma. So we can say home, and we will fetch from resource file. So we can say r dot string dot, we can say menu underscore home, and we have not created it yet, so we need to create this resource. So let's just create it. We can say it home, and then we need an icon for it. So we can say icons dot field dot home, which already comes with Jetpack Compose, so we don't have to create our own icon. And then we will have another tab for list screen. So we can say list, and here we can say r dot string dot menu underscore list, and let's create this one as well. So we can call it list, and we can use the icons for it. So icons dot field dot list. Now we need to create a companion object to set the call for two tabs. So we can call the tabs without creating an instance of this class, and also you can access its member using only the class name as a qualifier. So let's do that. Companion object, and here we can say function get tabs from resource, and then we need to provide the two parameters, or no, not two but just one, the resource. So we can say at string res of type resource, variable name resource, type int, and then we have to extend it with image tab. We just created it. Then we can return a when function to switch between the two tabs. So this when function is conditional expression with multiple branches. Here we have only two for the tabs, so we can say return when, and we can pass the resource in the as a condition. So we can say when resources or resource, and then we can say r dot string dot menu list. So if it's a menu list, then we will call the list. Otherwise we can use the else statement. So we can say else home. So this way we are setting the home tab as a default tab, and the when function matches its argument against all branches sequentially until some branch condition is satisfied. Okay, here we need to have a what is called semicolon. Yeah, semicolon. So that's it for this section, and we will keep building this screen in the next section. Now we will create the function for screens in which we will put the top app bar and the bottom navigation, where we will have the tabs and the data related to respective tabs. So let's create the function screens. So here we can say that composable function screens, and it's need two parameters, the view model and the function for selecting image. So we can say view model, and we can extend it to main view model that we created, and the function for selecting image. So we can say select image, which is obviously going to be of type long, followed by unit. Then we need a variable for image, so we can observe what's going on in the repository. So we can say value images, and we need the list type for the images for our data class images. So let's get the data class, and then we can say by view model. So we are using this reference view model to get the image list from our view model. So we can say view model dot image list. So let me just open our view model. So here we are trying to get this function into the screens. So we can say by view model dot image list, and then we can call the observe as a state. So observe as dot observe as data, and I cannot find this function. So looks like I am missing on a dependency, so I will have to check it. So let's go back to our build.gradle. So we have Android X Compose runtime. Let's see, we have runtime for live data. Can check here for no, we don't have the runtime for live data, so we need the dependency for runtime live data. So let's create it. I think we should put it with runtime, compose.runtime. I think I should put it here. So we can say implementation Android X dot compose dot runtime, and we can select the runtime live data. We can get rid of the version number and provide the compose version, and let's sync now, and when we should be good for using the state, observe as a state. So now the sync is complete, and let's see if we can use it. So we can say dot observe. Now we can find it. So observe as a state, and here you can provide the list. So we can say list of, and we need to import the android.compose.runtime. So we can just import it. So what it does, it start observing this live data and represents its value via state, and every time there would be a new value posted into the live data, the return state will be updated, and it will cause recomposition of every state. So next we need a function for selecting the tab from the bottom navigation, and for that we need to go back to our main view model to create the variable for selecting tab. So let's get to main view model, and here we need to create variable to select tab. So we can say private val underscore select tab. Here we need a mutable state, so we can say mutable state. So the mutable state is the mutable value holder, and it reads the value of this property during the execution of this composable function, and it's need to be of type int, and then we can initialize it with mutable state of. So we can say mutable state of, and we can initialize it with 0. It returns a new mutable initialized value with the new passed in value that we provide when we switches the tab, and it's a single value holder class, which means it can only have one value at any given time, which is what we want to achieve here. Then we need a state interface to save this value, so we can say value select tab of type state, and then we can pass the int here, and then we can use the, we also need to import this state. So just import the androidx.compose.runtime, and then we need to set the getter. So we can say get, and then we can set it to select tab. Then we need to create a function to select the tab. So here we can say function select tab, and here we need to provide the string resource. So we can say at string resource tab of type int, and then we can update the value from here. So we can say underscore select tab dot value equal tab, and we need to annotate it with the main thread, so it will run on main thread. So we can say at main thread, and as you know, the main thread is UI thread, as we discussed in the previous section, but since it's a very small function, to switch between tabs we can run it on main thread. Now let's go back to the screen, and here we can create the value for selecting the tab. So we can say value select tab equal, we can say image tab dot get tabs from resource, and here we can pass our view model dot select tab dot value. Then we need a value for loading to show the circular progress indicator when the app loads the data. So again, in the main view model we already have the mutable live data. We just need to create the live data for is loading. So let's here create the value for loading. So we can say value is loading of type live data, which is going to be of type boolean because it's either loading or not loading. Then we need another getter to get the value, and we can set it to underscore is loading the mutable live data, and we can get back to screen again, and here we can say value is loading equal boolean, we can say by boolean by view model. I think we should use the small by view model dot is loading, and we need the observe as state here as well, and here we can set the initial state to false. Okay, here we need to use the colon and not the equal sign. So in next section we will create a constant layout to put together the body and the progress bar for this screens function. So let's create the constant layout to put the body and progress of this screens file together. So we can say constant layout, and again, by now you must know that we need to create references for the constant layout. So we can say value, and we need a body and a progress. So we can say body and progress, and then we can say create reference. Now the first thing we need is to put the app bar on top of our screens. So for that we need scaffold, and scaffold implements the basic material design visual layout structure, and it provides API to put together several material components to construct your screen, and it ensures proper layout strategy for them, and it also collects necessary data so these components will work together correctly. So things like app bar or floating action button or bottom navigation are good example to put together under scaffold. So let's just do that. So we can say scaffold, and it's going to need some parameters. So we can say background color, material theme, dot colors dot primary surface, and then we can say top app bar, and here we just need to provide the app bar we created. So we can say app bar, and that's it. But we need to constant it, so we can say modifier equals modifier dot constraints as, and here we need to pass the first reference, so we can say body. Then we need to provide the scope, so we can say curly braces, and here we can say top dot link to parent dot top. After this we need the bottom bar, so for that we need another dependency for the bottom bar paddings and height, and provide window sets, which will you see later. So it's called accompanist insets dependency. You can find more information in link which is given in the resource. So let's declare the dependency. So we go to the project build, and here we can say accompanist version, and here we can declare the version, so 0.10.0, and we can sync now. Here I missed the typo mistake, so let's do it again. Then to build Gradle, and here we need to declare the dependency, so I can say here accompanist insets, and here we can say implementation com.google dot accompanist, then again accompanist dash insets, and then we can provide the version number, so dollar accompanist version, and let's sync now. Now we can declare the bottom bar, so we can say it needs to be under the scaffold, so here we can say bottom bar, and inside this bottom bar we can say bottom navigation, and it needs some parameter as well, so we can say background color, we will set it to purple 200, and then we need a modifier to set the navigation bar's height, so we can say modifier equal modifier dot navigation bar's height, and to set this navigation bar's height we need the insets, so it's coming from accompanist insets. Without it we cannot set this navigation bar height, so let's do that to 56.tp, and then we need to provide the row scope for this bottom navigation, because we have 2 tabs and they will put together in a row, so we need to declare a tab variable first. So on top of after is loading we can say value tabs, and we can get the tabs from our image tabs, so we can say image tabs dot value, and now we can use it, So where were we? Yeah, bottom bar, bottom navigation. So now we can run a for each lab on this tabs. So we can say tabs dot for each, and we can create a variable here tab, then we can follow it by lambda expression, and here we can say bottom navigation item. So bottom navigation item, not bottom navigation, but bottom navigation item, and it has some parameters. So it's a material design bottom navigation item. It is a recommended configuration for a bottom navigation item. Depends on how many items there are inside a bottom navigation. It provides all the necessary functionality for a bottom navigation. So to select, for selected, we can say tab equals double equals selected tab or select tab. Select tab, I really created a select tab. This should be actually selected tab, so let's rename it, so it makes more sense. So we can refactor it. Where is the refactoring? So now we have selected tab, and for on click we can just say, we can remove the to do, and we can say view model dot select tab, and we can provide the title. So we can say tab dot title. Let's move it to the next line so it will look easily, we can look it easily. And then we also need the icon, so here we can say icon, and for icon we can just pass the icon of type image vector. So we will choose the image vector, and here we can just say tab dot icon, and for content description we can just pass null, or you can pass a string if you want, does not really matter. Then we need label also, so we can say label, and for label we can simply pass a text here, so we can say text, and again we will be pulling the text from the string resource, so we can say string resource, and which needs an ID, so we can say tab dot title, and we need color, so I can say color equal color dot white, and here we have some problem with the color. Actually we don't have problem with the color, we have problem with the ID actually. Yeah, it should be, it's, I forget to actually get out from the small brace, and after label we need a color for selected content, so we can say selected content color. For the selected tab, so we can say local content color dot current, and We also need a color for unselected content, means unselected tab. We can set it to same. If you want, you can set it to something else. It's your choice. And we need the paddings to apply additional space which match the height of the navigation bar's height along with the bottom edge of the content, and additional space which matches the width of the navigation bars on the respective left and right edges. So we can say modifier equals modifier dot navigation bars padding, and it will just apply by itself. So this is where the scaffold components complete. Let me check it again. Yeah, here it's complete. And now we need to declare the inner paddings so we can fill the screen with the image and their details. So here we can say inner padding followed by lambda expression, and here we need crossfade. So crossfades allow to switch between two layouts with a crossfade animation. So we can say crossfade, and it's require a target state. So we can say selected tab, and then we need to provide the destinations so we can switch between them. We need to create a destination first. So destination variable, and now we need to provide the lambda expression. Then we can run the when conditional expression. So we can say when destination, and here we can just say image tab dot home. So if we are on home, we can switch to display images, and we just need to provide the images. So we can get rid of this equal, and we can get rid of this equal as well. And then we need another destination for list. So we can say here list image, which we have not created yet. So let's just create it quickly. We won't put anything in this file yet. We can just say list image for the sake of the project. Let's call it actually list screen, not image. So we can rename it. So list screen, and here we will just say list screen, and it's okay. We don't have anything inside this list screen, so that's why it's not getting it. So let's quickly put something inside it. So what we can put is we can just put this composable function. Here we can put this composable function. We can get rid of this parameter, and here we can simply say image list tab, and here we can call the greeting function actually. So after inner padding, we can declare the surplus progress indicator. So where it ends here. So after inner padding, we can say circular progress indicator, and here we can provide some parameters for it. So we can say modifier equal modifier, and we need to constant it. So we can say dot constants, as we can provide the progress, and then we need to provide the constant scope. So we can say top dot link to parent dot top. We want this indicator to be in the middle of the screen, so we will have to constant it from all sides. Now we can say bottom dot link to parent dot bottom, then we will have to link it from start. So we can say start dot link to parent dot start, and then from end side we can say end dot link to parent dot end. So in this way it will show in the middle of the screen vertically and horizontally. Now we need an extension for the visibility of circular progress indicator. So let's create the extension. So in our extension files, we can say new modifier extension, and here we need to create a function for the visibility. So we can say function modifier dot visible, and here we need a parameter for visibility. So we can say visibility of type boolean, and it need to be extended by modifier. And in this function we will return the value of color. So we can say if visibility so we will say this dot then 1f, else we can say this dot then 0f. Okay, we need to annotate it with at stable, and here we need to provide the alpha. So inside this alpha we can pass this 1f, and here we also need to provide the alpha and pass the 0f. So depending on the value of is loading, it will change the alpha, so it will be seen or disappear the circular progress indicator. So back to screens, here we can now here say dot visible, and we can pass the is loading. So that's it for this section, and from next section we will be building our main screen. In this section we will set up our main screen in order to be able to run the app, because we have built quite a lot in this app but have not run the app once. So we need a couple of things more before we can run this app. So we need to create routes and nav controller to navigate in the app. So let's create these things in main screen. So we will create our main screen here in main screen package. So let's create new file and call it main screen. So in this main screen, we need to create a sealed class for routes. So we will say sealed class nav screen, and we need a parameter for route. So we can say val route of type string. Then we need to create an object for home route. So we can say object home of type nav screen, and we can create the route here by saying home. So the sealed class is an abstract class with a restricted class hierarchy. So it will only can be accessed through this main screen. Only this main screen can access this sealed class objects because it's defined inside this class. This provide more control over the inheritance, and they are restricted but also allow freedom in state representation, and this sealed class cannot be extended by any other class. Now we need to build the navigation in the main screen function, and for that we need dependency for both Android X navigate and Hild navigation. So let's go to project level build file. Okay, here we made a typo, so we can correct it by putting the colon. So let's go to the project level build Gradle, and here we need to define the version of those navigations. So first of all we need the compose navigation, so we can say compose navigation, and the version is going to be 2.4.0 dash alpha 09, and then we need the hilt navigation, so we can say 1.0 dash alpha 03, and here we need another O, and we can sync now. Now we can declare the dependencies in the app level build Gradle file. So here I will say navigation, and let's define the Android X navigation first. So we can say implementation Android X dot navigation colon navigation compose, and we can pass the version. So we can say navigation compose navigation, and then for the hilt navigation we can say implementation Android X dot hilt, and we can choose the hilt navigation compose, and then we can pass the version for the hilt navigation actually. So yeah, this one, and we can sync it. Now back to main screen, and now we can create our main screen function. So we can say at composable function main screen. Here we need to create a nav controller first. So we can say value nav controller, and we can use remember nav controller. It creates a nav host controller that handles the adding of compose navigator and dialog navigator. Then we need to create a local context. So we can say value context, and we can set it to local context, not absolute, local context dot current. Then we need to apply window insets value to the local window insets. So here insets mean size. Window insets are insets of system view like top app bar, status bar, navigation bar that are applied to the window so that they can be applied in proper layer. Otherwise they could overlap on each other, or the app bar and the navigation could go into background layer and you won't able to touch them. So window insets make sure that every component is in its proper layer and not messing with some other component layer. And it's provided by Google accompanied insets, which we declare in the previous section. So we can say here provide window insets. Then we need to create a nav host here. So we can say nav host, and it requires a nav controller. So we can pass our nav controller value which we created. So we can say nav controller, and we don't need the nav graph. We need a destination, we need a start destination. So we can say start destination, and we can set it to nav screen dot home dot route, and then we can provide the nav graph builder. So in this nav graph builder we create the routes through composable function. So we can say composable, and here we can pass the route. So nav screen dot home dot route, here we need to create the nav backstack entry, and for that we need to reference to our main view model. So we can say value view model equal hilt view model, and here we need to provide the main view model. So we can say main view model. Then we can set our screens. So we can say here screens, and it need two parameters view model. So we can pass our view model reference here, and for select image we can just leave it as it is because we have not created the detail screen yet. So we cannot go to detail screen, so we will leave it here. After that we need the toast in case of API response failure. So we can say view model dot toast dot observe, and Here we need to provide a life cycle owner. So we can say local life cycle owner dot current, and then we can create our toast. So we can say toast dot make text, and here we need to provide the context. So we can say context, we can pass the context here, then the message. So the message can simply be it, so we can pass the it, and then we need to pass the length of the duration for the toast. So we can say toast dot length short, and then we can finally call the show method function. So dot show, and then we can create a log. So we can log cat the error as well. So we will just say log e, and here we need to import the tag. So let's import the content value tag, and here we can say main screen, and we can pass the it. So we can say plus it dot to string, and yeah, that's it for the main screen for now, and that's also for this section. But let me also do a quick fix in the main view model, because I made a mistake. I did not make a mistake, I just forget to initialize the view model. So here I just need to initialize it. So I can say init, and let's log this as well. So we can say log d, and here I want to get rid of tag, and I just want to provide the message. So I can say view model, and then here I can say view model initialized. So that's it for this section, and in the next section we will set up this main screen into the main activity, and then we will fine tune the project to run on the emulator. So now we will bring this main screen to our main activity file, which provides the entry point for the application. So let's go to the main activity. So here we first need to create a separate class to inject our image loader function, which we created in the network module. If you remember, in our network module we have this image loader function. So now we need this image loader to fetch images from the network. So we can use it here in main activity. So let's create the class. So let's first get rid of this boilerplate code, and we also need to get rid of this greeting, and here we can say class root view model add inject constructor. Here we can initialize the image loader. So we can say val image loader, and it you can see that we have a little icon here, and if we click it, it will take to the network module. So it's saying that we are now referencing this function, this held function, in our main activity. So after that we need to extend this class with view model. So we can say colon view model, and inside this class we just need to initialize this class. So we can say init, and we can log it. So we can say log d, and we need to import the tag. So just import it, and in message we can just say initialized root view model. So we need this image loader function to provide the support for loading images from network. And now we have to annotate this class with at hilt view model also. So we can say at hilt view model. Now we need a reference of this root view model in the main activity. So here we can say value view model of type root view model, and we can say by, I think we need this one, yeah. And we also have to annotate it with at visible for testing. So we can say at visible for testing. So what it does, it relax the visibility for this field so that it is more widely visible. Otherwise we will have to make it private, and hilt just does not work with private variables. Now we need to cut this entire piece of code. So we can cut it, and we need to put it into composition local provider. So we can say composition local provider, and we need to put all this code inside this function. So composition local provider, what it does, it binds value to providable composition local keys, and it reads the composition local using composition local dot current, and it will return the value provided in composition local provided's value parameter for all composable functions that are called directly or indirectly in this content. So now we need to provide the coil image loader in this composition local provider. So we can say, we can remove these values, and here we can say local coil image loader, and we can say provides, and here we will just pass our image loader. So we can say image loader view model dot image loader, and then we need to provide annotation for this main activity. So hilt can know that this file is the entry point of this app. So we can just say here at Android entry point. Now we need to make this app a hilt app. So for that we need to create a class with same name as the name of this project. So the name of this project is image repository app. So let's create a class. Here we can say new Kotlin class, and we can say image repository app, and we just need to extend it with application, and we need to annotate with hilt Android app. Now we need to go to manifest file to provide some additional information about the app. So we can close all of these screens, and we can go to manifest file. Here we need to first provide the permission for internet using. So we can say users permission, and there we just got the first permission for internet. So we can use it, declare it, and then we need to provide the application name in the application block. So here we can say Android name, and as it's already detected the name of the app, so we can say image repository app, the class we created just earlier, this one, it will work as the name of the app. Now we need the base class component activity for activities that enables composition of higher level components. So after the activity tags ends here, we can declare the component activity. So we can say activity, and we have to provide the name. So we can say Android X dot activity dot component activity. Then we need the provider for startup, and for that we need startup dependency. So we can go to project build again, and here I can say startup equal 1.0, my numlock is off, we can say 1.0.0, and we can sync it. Then in the app level build we can declare the dependency. So here we can say startup and then implementation Android X dot startup, and we can choose the startup runtime, this one, and then we can provide the version number for it. So we can say startup, and then we can sync again. So the app startup library provides a straightforward performant way to initialize components at application startup. It is used to streamline the startup sequences and explicitly set the order of initialization. It also allows you to define components initializer that share a single content provider, and this can significantly improve at app startup time. So let's declare it in manifest file. So after component activity we can say provider, and the first thing we need is the authorities. So we just need to use our Android X startup. So we can say com, we need to provide the package name. So I can say com.pivotalpeaks, and then the name of the app. So we can say image repository app, and then we can provide the Android X dot startup. So we can say Android X dash start up. Then we need the name. So we can provide the Android X dot startup dot initialization provider, and then we need to provide a couple of more parameters. So we can say Android dot exported, we need to make it false. So it just indicate whether this application component is available to other applications. So it is a standalone application and does not need to communicate with other application. So we can say false. And then we need the tools dot node. So we can say tools dot node equals, we can provide the merge or remove, both will work. And why it's giving me red light? Okay, I need to import it. So alt plus import, alt plus enter import. So this attribute ensures that the manifest merger tool properly resolves any conflict entries. In case of if we have multiple manifest file, I mean the APK can only have one manifest file, but the Android Studio may contain several manifest file provided by the main source sets, build variants and imported files. So in that case, if there is a conflict, so what we want to do, so we can either merge it or remove it. So the merge is the optimal solution, so we should use merge. So that's it, and I think we should be running the app. So let's try and run the app and see if we can get it running. So I am going to open my emulator and just I will start this one. So the emulator is up and I'm just going to click play button to run the app and see how long it takes to run the app. And I have tried to run the app and we ran into some problems, actually a lot of problems. So we will fix all of these problems in the next section. So do not worry, we will get all of them. So I will see you in the next section. So this is where we end up in the last section with the errors. So before we move on and pinpoint the errors, first we need to add a plugin for Kotlin Android, which I should have done much earlier, but for some reason I forget it. So we need to go to the app level build Gradle, and here we need to add the plugin for Kotlin Android. So we can say id and then Kotlin dash Android, and then we can sync it. So let's sync now. So what was the problem? Actually the problem was in the build log, but since we sync it, the log is gone, so I have to run it again to see the problem. So let's do it again. So yeah, now we have got the problem, and let's see what it is saying. So it's saying that dagger missing binding, and it's saying that for image service network.image service we are missing the bindings for dagger. So let's go there and see. So we can just click here on this class and it should take to this network class, and it did not take us to that class object. So we can go by ourselves there. So I am going to close this and let's go to our network module. So network module, and here it's saying that we have problem with image service. So let's go to the image service. This is where the problem is. So here I forget to annotate it with add provides and at a single tone. So we need to do that. So let's do it. So here we can say at provides and then at single tone, and let's run it again and see what happens. So after rectifying that problem, we don't have any build problem, but seems like we still have some problem because the screen is showing blank, so we are not getting the images. So we need to work on those. Also, we have forget to use the inner padding in the screens file, and the content scale is never used. So we need to use it, otherwise the image cannot be scaled. So I think that is the problem, that the images are not loading. So let's go to the network image, and here the content scale, because it cropped the images and it has not been used in the coil image. So let's use it real quick here. So we can say content scale equal, we can pass the content scale that we created, and again we are having a bit of problem. So let's see what is that. Cannot find a parameter with this name. Okay, we need to add this outside of this shimmer params. Okay, let's put it here after the image URL. So we can say content scale equal content scale, and let's run it again and see if this resolve the problem. So it did not resolve our problem completely. Also we had to apply inner padding in our screens, because we also seems to forget that. So this inner padding has not been applied. So let's apply this inner padding. So for that we need to create a modifier. So we can say value modifier equals modifier dot padding, and here we can say inner padding, and then we need to apply this inner padding into our image tab. So here we need to provide the final parameter as a modifier. So we can say modifier, and let's run it again, and it did not run again. So after doing some debugging and testing, I realized that I have forget to call this main screen in our main activity. So that's why we could not get anything on our screen. So let's just call the main screen in the on create view function, on create function in main activity, and then we can run the app. So let's do it. And it has been installed and about to launch. So we will see. So you can see that we have managed to run the app, but not the way we wanted. But at least we got something running, and seems like it is the problem with maybe a staggered vertical grid. Something I missed. Maybe it's the width of the image. So yeah, we were able to run the app. And so in next section we will be fixing this issue to fix our grid, and we can also switch to the list tab. So I can click here. So you can see I have not put anything inside the list screen, so I just put this message image list tab. So in the next section we will fix our staggered vertical grid to display the images properly, and I will see you in the next section. So now we need to fix the home screen, as it's only showing one column, but we need at least two columns. So I realized that I did a typo mistake when I was creating the staggered vertical grid. So here in the staggered vertical grid, in the shortest column function, the minimum height should be set to int dot max value and not to min value. So we can actually log this column and see how it works. So just before we return the column, we can log it. So here we can say log d, and here we can say column, and then we can say plus, and here we can log the column to see how it works. So we can run this app. So we can go to the logcat and search for the shortest column. So you can see that with minimum value we are only getting one column. So you can see we never get the column 1. Of course, it start with 0 indexed, so don't confuse with that. So you can see that all images on the first column and we never get to the second column. So now we can change it to max value and see how it works. So here we can say max value and then we can run it again and then we can log the difference. So now we are getting all the images properly in both columns. We can also see that in the logcat. So we can just search for it. So now you can see that it start with column 0. So it start with here column 0 and the second image is placed in column 1. So you can see that it's here and then 0 1 0 1. So you can see the pattern here 0 1 0 1. So it's able to actually put the images in both columns. So that's it for this section. Let's now move on to our list image or list screen to create our list image screen. So I'm going to close the emulator and I'm also going to stop the process and let's work on our list screen to create the list of images. So I am also going to get rid of this function completely. So first we will create a list image function to display a single image and then we will create another function where we will pass this list image function in a lazy column to display the list of all images. Lazy column is a better version of recycler view which is a lot less complex and also it removes a lot of codes. So let's start. So let's remove this import and we can say add composable function list image. We need some parameters. So first will be the image itself, the image from data class. So we can say image and we need to choose our data class. Second is going to be a function for selecting the image. So we can say select image. We have done this already, all right. So only the layout is going to be a bit different. Most of the things will remain same from the home screen. So here we can say long and then the unit and then we need modifier. So we can say modifier equal modifier. Then we will bring our surface. So I can say surface and it's going to require some parameters. So we can say modifier equal modifier and then I can say dot fill max width and then I also want to apply some padding. So I can say padding 4.dp and then we need to import the dp as well and then we need the clickable feature, clickable function. So we can click the images. So we can say dot clickable and we need the clickable message with clickable function with curly braces. So here we can say on click and on click we can say we can just pass the select image function and then here we can provide the image id. So we can say image dot id and then we can apply some colors. So we can say color dot color equal material theme dot colors, and we can say dot background, and then we can also declare elevation, so we can say elevation 8 dot dp, and then we can finally provide a shape for it, so we can say shape, and we can go with rounded corner shape, and again for this I'm going to go with 8 point dp. So that was for surface, and let's remove the import from here, sometimes it just appears. Now we need a constant layout, so let's say constant layout, and here we can apply some padding, so we can say modifier equal modifier dot padding 8 dp, and after that we need to define the references, so we can say value, and I am going with the same old image pic, title and height, and then here we can say create reference. Now we need to bring in our network image, so we can say network image, and for URL we can say image dot URL or image URL, and for modifier we can say modifier equal modifier, and then we can say dot constraints as, and we need to pass the variable, so we can say image pic, then we need to provide the scope, so here we can say center vertically to, and we can say parent, and then we can say end dot link to, we can say title dot start, so we are linking the end of the image to the start of the title, so they can be side by side. Then we need to provide aspect ratio, so here we can say dot aspect ratio, and we can say 1f, then we can say fill max size, and then we can clip it with rounded corner, so we can say dot clip, and here we can say rounded corner shape, and we can provide the size of 4 dp. Then after network image we need the title, so we can say text, and for text we can say simply say image dot not height, image dot title, then we can apply the constraints, so we can say modifier dot, let's bring it to the next line, so we can say dot constraints as title, then we can provide the scope, so we can say start dot link to, and we can say image pic dot end, so this will again tie the start of the title to the end of the images, like side by side, like here we mention here, and then we can apply some padding, so we can say dot padding, and we can say horizontal equals 12 dot dp, and then for height we can say, we can just copy it, and we can say image dot height, and here we can change the constant to height, and we can say start.link to image pic.end, and also we need the topping to be linked with bottom of the title, so we can say top.link to title dot bottom. So in this way it will be linked below the title, and then here we need some padding for start and top, so we can say start equal 12.dp, and also we need topping padding from top, so we can say 4.dp, and yeah, so we are done for a single image. And now we need to create a function to display the list of images, so we can go above and we can say here add composable function list, and here we can say images, so we can differentiate between these two. And here we again need the data class, the image data class, but now we need it in a list, so we can say images, and here we can provide list, and then we can say image. Then we need the select image function, so we can just say select image and our classical modifier, so let's say modifier. Here we need a variable in which we can save the state of the list, so it won't have to recreate the state at every recomposition. In other words, it will always remember what it already has and will keep adding to it as we scroll through the list. So we can say we need to create a state variable, so we can say val state equal remember lazy list. Then we need a column, so we can say column, and here we need some modifier, so here we can say modifier equal modifier dot status bar padding to apply the additional space which matches the height of the status bar's height along the top edge of the content. It applies the additional space which matches the height of the status bar along the top edge of the content. Next we need a background color, so we can say dot background, and we can say material theme dot colors dot background. Then we can use the lazy column in the column scope, so here we can say lazy column, and we can remove the content and set the state. So in this lazy column we need to provide the state, so we can say state equal, we can provide the state variable we created, so we can say state equal state, and then we need content padding, so we can say content padding, and then we can provide the values for it by saying padding values, and we can then pass the values, so we can say 4.dp. In this lazy column now we need to provide the scope, so we need to add list of items, so we can say items, and again we need the small braces, not the curly braces, so we can say items. We need items, not item, sorry, my bad. Let's see, we can say items, and here we can set the items to the images variable we created, so we can say items equal images. Then we need item content which will display the content by a single item, so we can say item content, and here we can say image. We can create an image variable here, and then we can pass the lambda function, and then we can call our single image list image function. So we can say here list image, and here we can set the image to image, and we can set the select image to select image function, and that's it for this list screen function. Now we need to call this list image function in our screens. So here we can say, as it's already showing some error because we changed the parameter for the list screen. Actually we don't have the greeting function anymore. So here we can say list images, and we can just remove the equal sign and the equal sign here, and we can pass the modifier, and hopefully it will run as we would like to see. So let's run and see if we get everything right. And the app is up and running. So let's click on the list image on the list tab. So let's click it. Oh, we got it in the list fashion, but it's too big. The image is too big, so we need to rectify it. So let's do it. Okay, so the height seems to be too big, so looks like we have missed the height part in the image. So yeah, here we need to provide the height as well. So let's say height, and let's give it a value of 64.dp, and hopefully it will resolve the problem. So let's run it again. Let's click it again and see if we have resolved the issue. So we have resolved the issue, and we can see all the images in a list. So that's it for this section, and in the next section we will be working on our detail screen. So if we can click on this link or in this image, we will see the details and description about this mountain. So yeah, I will see you in the next section. So from now on we will be working on to create the details screen for our image repository app. So for that we need a couple of components. We need a details repository class, so we can fetch the details of a single image. Then we would need a view model class for details screen. So let's first create the details repository. So in the repository package, let's close these two screens. So in repository package, we need to create a detail repository class. So we can say details repository. So in this class we will inject the image DAO through injection constructor. So we can say at inject constructor, and here we need a value for image DAO. So we can say private val image DAO of type image DAO. Inside this class we will create a function to fetch details of one single image. So we can say function get image by ID, and we need to provide the ID as a parameter. So we can say ID of type long, and then we need the get image from our image DAO. So we can say image DAO dot get image, and we can pass the ID as a parameter. So let's go to the image DAO and recall the function again. So we are querying this function in our detail repository to fetch one single image details through this function. So that's it for the detail repository. Now we will create the view model for details screen. So we can close this, and first we will create a package for detail screen. So let's create our package. We can say details screen. Now we will create the view model. So we can say new class details view model. So now we will constructor inject details repository class in this detail view model class. So we can again say add inject constructor, and here we can say private val details repository. We can select the details repository. Then we need to extend this class to view model. So we can say colon view model, and we also need to annotate this class with the hilt view model annotation. So here we can say at hilt view model. Now inside this function we need a mutable live data variable for image details. So we can say private var underscore image details of type live data, and we need to pass our image data class. So we can say image, and then we can initialize with mutable live data. Now we need a getter function for this mutable live data. So we can say value image details of type live data, and again we need to pass the image data class, and then we can call our getter function. So we can say get, and then we can set our mutable live data image details, so image details, to this getter function of image details. Now we need a function to fetch the details from the repository using our image DAO. So we can say function get image, and we need to provide the ID of type long with capital L long. Here we can say our image details mutable live data, and we can initialize with details repository dot get image by ID, and we can pass the ID as a parameter, so ID, and then we need to annotate this function at worker thread. So we can say at worker thread. So it should only be called on worker thread, which runs in background and does not block the main UI thread. Now we can finally initialize this view model by saying init, and we can log this as well. So we can say log d, and here we can just say we need to import the tag. So just import the tag, and here we can say initialized detail view model, and we are done. So after creating details repository and details view model, now we can create the image details screen. So let's create the image details file in detail screen package. So here we can say new Kotlin file, and here we can say image details. We need to select the file. So first we will create a composable function for the detail screen. So we can say add composable. We can say function image details body, and we need some parameters. So the first parameter is going to be our image data class. So we can say image, and then we need a function for going back to the main screen. So we can say press on back of unit. Now inside this function we need a column, so we can say column, and then we need some parameters for this column. So the first thing we need is the scrolling functionality in case of a longer details screen. So we can say modifier equals modifier, and here we can say dot vertical scroll, and we can use the remember scroll state, so this function. Then we need a background color, so we can say dot background, and we can choose the color from material theme. So we can say material theme dot colors dot background. Then we need to fill the max height, so we can say dot fill max height, so it will fill the whole available height. Then in the column scope we need to create the references for the detail screens. So for that we need a constant layout, so we can say constant layout, and here we can create our references. So we can say value, so we can say image pic, and title, and height, and what else, we need the details, so we can say image details, and finally we need an arrow icon, so we can press the back button and we can say equals create reference. So for going back to main screen, we can also just use the back button on the device, but it's nice to have this function as well to going back. So let's work on our constant layout. So the first thing we need is the image. So let's bring our network image. So we can say network image, and URL equals, we can say image dot image URL. Then we need the modifier to constant it, so we can say modifier equal modifier dot constants as, and we can pass the image pic reference, so we can say image pic, and then we need to provide the scope, so we can say top dot link to, and we can say here parent dot top, so the image will be always on the top. Then we need to fill the max width, so we can say dot fill max width, and we also need the aspect ratio, so we can say aspect ratio, and I am just going with 0.80f. So you can choose whatever the number you would like to. Now we need the text for the image title. So we can say after the network image, we can say text, and here for text we can simply say image dot title, and we can provide some styling. So we can say style, and we can choose material theme dot typography, and we can select there are so many options. I am going with H5. So H5, then we need overflow, so we can say overflow, and we can choose text overflow dot ellipsis. Then we need to constant it, so we can say modifier equals modifier dot constants as, and we can provide the reference for it, so we can say title. Then we can provide the scope for it, so for scope we can say top dot link to, and we can say image pic dot bottom, so it will be at the bottom of the image. And then we need some padding, so we can say dot padding, and we can say for start we can say 12 dot dp. Let's import the dp, and then for the top we can say 16 dot dp, so it will have a padding of 16 dp from the top, I mean from the bottom of the image to the top of the text. And then we can do the same for the height, so I will just copy this text and paste it here, and here I can say image dot height, and for typography we can choose the body 2, and we don't need the overflow for this. So let's change the reference for constant. Here we can say height. Actually for text we can say at both, here as well we can say text equal, we should provide a string here actually, so it would make sense. So we can say name plus, and then image dot title, so we will know that it's a name for the mountain. And we can do the same here for the height as well, so we can say text here, and here we can say HEIGHT height. And what else, we need to link it to the this title, so we can say title dot bottom, and padding can be same. And then we need the last text for the details of the image, so we can do the same again, so we can copy it and paste it here, and here we can say details, let's go with the capital, and here we can say image dot height title id, should have been a description or something. Okay, image dot no, it's not showing the description. So let's go back to our image data class and see what is the problem. Where is the data class? Yeah, here we have. Okay, so I have forgot to include the details value, so here we can just say value, and we can say disk, and type is string, and I think we should be good. So get back to image details, and here we can say image dot description, and For typography, we should let it be body 2, and we can link this to height. So we can say height dot bottom, and padding can remain same. So after this, we need the icon for the back button. So here we can say icon, and we can choose the image vector. So we can say image vector icons dot filled, and here we can select the arrow back. So arrow back. For description, we can just pass null. You can pass any string you want, and then let's go to the next line, and here we can provide the tint color. So we can say tint, and we can say color dot white. Then we need our modifier to constant it. So we can say modifier dot constant as, we can say arrow. Then we need to provide the scope. So here we can say top dot link to parent dot top. So it will be on the top of the parent. And we also need some paddings. So we can say dot padding, and we can provide the padding of 12 dp, and we need to make it clickable, because otherwise there is no point of having the icon. So here we can say dot clickable, and in this we can provide the on click function. So on click we can say curly braces, and we can say press on back function. And that's it for the body of our image details. And now we need another composable function, so we can observe the details of the image through details view model. So we can go to the top, and here I can say add composable function. Here I will say image details, and in this function we need the details view model as a parameter. So I can say view model, and I can select the details view model, and the press on back function to get back to main screen. So we can say press on back. Inside this function we need a variable for details, so we can observe the details view model. So we can say value details colon image question mark, and we can say by view model dot, we can select the image details that we created in the last section, and then we can say observe as a state. So we also need to import the runtime, the compose runtime. So it starts observing this live data and represents its value via state, and every time there would be new value posted into this live data, the return state will be updated, and it will cause the recomposition of every value of the state. So now we need to run a let function on this details variable, so we can fetch the details of the image. So we can say details question mark, and then say dot let. Then we need to create a image variable inside this let function. So we can say image, and then followed by lambda expression, and then we can call our image detail body. So we can say image details body, and we can just say image and we can pass the another function for press on back. So we can say press on back, and we need to remove these curly braces. We don't need those. So this let function is an inline function which calls the image body functions with the image as an argument, and it returns the results. So that is for this section, and in next section we will create route for the details screen. In this section we will create routes and navigation composable for the image detail screens. But first let me do a correction in this image details file, as I forget to replace the constant for image details. So let's do that quickly. So here in details we need to constant it as image details, and now we are good to go. So let's create the routes for image detail screens in main screen file. So in main screen we need to create an object for image details. So we can say object image details of type nav screen, and here we can create the route. So we can say image details. Then we need a const variable route with an argument. So we can say inside this object function const value, and we can say route with argument of type string, and we can say image details / in curly braces we can pass the id for image, so we can say image id. Then we need another const variable for the argument itself, so we can say const val argument. It's going to be of same type string, and here we can say image id. So that's it for the shield class. Now we need a navigation composable in main screen function. So in provide window insets, after the home composable navigation, so after this we can create another navigational composable. So we can say composable, and in this navigation composable we need two parameters, a route and the argument. So we can say here route, and we can say equal nav screen. Oh, we already have equal, so we can say nav screen dot image details dot route with argument. And for the arguments we can create a list of arguments. So we can say argument, and here we can say list of, and in this list of we can provide the nav argument. So we can say nav argument, and in this nav argument we can say nav screen dot image details dot argument. Then we need to provide the type of argument. So the argument is image id and its type is long. So we can say type equals nav type, and we already have bunch of types, but we need the long type. So we can say nav type dot long type, and we can bring it to the next line. Here we need to create the backstack entry. So we can say backstack entry followed by lambda expression. Here we need the details view model, so we can say value view model equal hilt view model, and we need to provide the details view model, so we can say details view model. Then we need to have a reference for the image ID, so we can say value image ID equal, we can say backstack entry dot argument, and then question mark dot, we can say get long because it's a long type, so get long, and we can say nav screen dot image details dot argument. So as soon as we click on an image, we will have the reference of the image ID, and we can pass that ID to get image function that we created in details view model. So we can say we need the get image function from the view model, so we can say view model dot get image, and here we can pass the image ID that we just get from clicking, and it's a type mismatch required long found long, so both of them are long. Okay, here we forget to return the composable in the image ID value, so here we need to say question mark colon, and we can say return add composable, and now the error has gone. Now we can call the image details screen after getting all the required references from the backstack entry, so we can say here image details, and we need to provide the view model, so we can just say we can just pass this view model, and then we also need the functionality to go back to the main screen. So here we can call the navigate up function, so we can say nav controller dot navigate up. So that's it for the image details screen route, and we also need to provide the route when we click the image in home screen or list screen. So in home route composable, here we left this select image function, so now we can say here nav controller dot navigate, we just need the navigate, not navigate up, and here we can say colon, not colon, double quote, and we can say dollar sign, and then we can say nav screen dot image details dot route, and then we can say forward slash and then dollar, and then we can pass it to it. So now if we click the image in home screen or list screen, it will take us to the image details screen. So now we can run the app and see if we did everything right. So let's run it. So I am going to open my emulator and I'm just going to run it, and it's up, and oh, the app has been crashed. So let's see the logcat. So let's see what happened actually. Room cannot verify the data integrity. Looks like you have changed the schema but forget to update the version number. Okay, so yeah, in the last section when we changed the image data class, so yeah, we have changed the image data class, and so we have two options here. Either we uninstall the app from the device, or we can increase the version number in our app database class. So let's increase it and see if it start working. So here I am going to say 2 and I'm going to run it again, and let's see if it resolves the problem. So it's about to install, and now it's up and running. So let's click it and see if we get the image screen. And here we are able to navigate through the image detail screen. So here we can see the name appears, Mount Everest, and height, and there is a little details. So we can actually zoom in the device to see a little bit better. It looks like too much zoom, and we can go back by clicking the arrow. So let's click on another image, and yeah, I think it's working. So it's looking good, and you can play with the typography and fonts to increase the font size, because it looks like it's look too small, so you can play with that. So guys, that's it for this course, and I hope that you learned quite a lot from this course. Now I think you are ready to make an app by yourself using Jetpack Compose, and by now you know how powerful and convenient Jetpack Compose is. By decreasing at least half of your work and by removing the XML part of UI, you must also notice how easy it is to create a list in Jetpack Compose compared to XML based programming. Now, with Jetpack Compose, you don't need to create recycler view and adapter for recycler view. It reduces a lot of work for sure. So go ahead and find some free API on the web, and there are plenty of them if you want to make an app by yourself, or better, if you know how to create your own backend, then you should create your own API and make an app to connect the API. It does not have to be an image repository app. You can make any app you want. So goodbye for now, and I will see you soon.